If numbers were people, number system surely would not be a democracy because it has some royal numbers which are more powerful, more intriguing and more popular than most of the other common numbers. These special numbers have captured the imagination of so many brilliant minds that they have almost achieved a cult status. Today, we will discuss about one such number, E. However, instead of going through higher mathematical concepts, we will try to derive its value using simple calculation using Microsoft Excel. So let's start our journey in understanding E. What is E? Well, this is simply a number between 2 and 3. More precisely, between 2.5 and 3. Even more precisely, between 2.7 and 2.75. But if you want to be extremely precise, we should say that it is somewhere between 2.71828182845 and 2.71828182846. Well, but what is the exact value? It turns out that you can never really arrive at the exact value in decimal representation. That's why we have given it a nice symbolic representation, the letter E. Interestingly, to understand E, we have to focus on something which everyone understands: money. Let us say a person has taken a loan of 100 rupees at an insanely high interest rate of 100%. Now, if the compounding is done every year, obviously the final value after a 1 year will be 200 rupees. However, if the compounding is done after every 6 months, then the final value will be 225 because for every 6 months the interest rate will be 50%. Similarly, if the compounding is done in a quarterly basis, the final value will be 244 as the per quarter interest rate would be around 25%. As you can see, the final value is increasing just by changing the frequency of the compounding. So the natural question is, how far will it go? If we change the frequency even higher, will it increase indefinitely? This question not only has a theoretical curiosity but also has a huge practical implication. Let us try to find the solution using Excel. As you can see, the number of periods is increasing strictly, and we want to find the final value after 1 year, assuming the per annum total interest rate is 100%. You will observe that the final value is definitely increasing with the number of periods. However, the rate of increase is decreasing. In fact, it settles down somewhere between 271 and 272. Mathematically, it can be proven that this never reaches 272. The ratio between the final value and the original value will settle down somewhere around 2.7182. And this number is nothing but E. Mathematically, this kind of behavior of a sequence is often termed as the limit of a function. Now, one may ask that we have used a very impractical interest rate of 100%. What if we use a more practical number, let's say 10% of interest rate? It can be shown that even in those cases, the limiting value can be represented as e to the power interest rate. In terms of Excel, we can use the function exp. All this is fine, but do we really need this number? What is the practical use of this number E? Well, E is such an important number that this is intricately linked with many other fields of studies, including prime numbers. And as you know, prime number is the backbone of public key cryptography. So for all the digital transaction that you do, somehow in the value chain, E is responsible for that also. So that was a quick introduction of E. I have attached the Excel sheet in the description box. If you have liked the content, please consider giving it a thumbs up and write in the comment box what other concepts you would like me to explain it here. See you in the next video.